Hi all. Welcome to the Chapter 8 lecture videos. We're going to start out today with section 8.1, which is talking about solving linear systems of equations. And then in the next video, we're going to talk about solving non-linear systems of equations. So those are the only two sections from Chapter 8 that we're going to worry about for this class. So go ahead and get out the Chapter 8 note sheets. You should be able to download a blank version of these from the handouts page on my MATLAB. And if you want to print it out and follow along with my notes, or if you just want to follow along on some scratch paper, or if you've got this on a tablet or something, that would work too. So what we're going to talk about is systems of equations. And so we're starting out with this idea of systems of linear equations. But in general, any collection of two or more equations is called a system of equations. The solution set of a system of equations is a set of all points that are solutions for all equations in that system. And these systems fall into three categories. A system that has at least one solution is called consistent. And a consistent system with a finite number of solutions is called independent, because the lines or the equations are independent of each other. However, if a system has infinitely many solutions, we call this dependent, because what's going to happen is the graphs actually are the same graph. The equations are actually two forms of the same equation. And then if a system has no solutions, we just do the opposite of consistent, which would be inconsistent. So when we're talking about linear, this is what those three options look like. So I'll just draw three graphs here. Okay, so the first one is if we have an independent system, then there is at least one solution, but not infinitely many. So for that to happen with lines, what we have is we just have two lines that intersect, and this point of intersection is the solution, because that point works for both equations. Then we have dependent systems. These are systems that never intersect. So they would look like that. Wrong one. Got ahead of myself. Dependent systems are ones where they're always the same. So that actually means that these would be one line. They'd be the same line. And then last but not least is inconsistent. And these are lines that never intersect. So those would be two parallel lines, like so. Okay, so that's the idea. So what we want to talk about is, well, how can we figure out where these solutions are? And then also, how can we tell which type of system we're looking at? So there's basically three methods for solving systems of equations. The first one is graphing. So we can solve systems of equations simply by graphing them. Okay, so let's try doing that in our Class Calc app. So if you open up Class Calc and you go to graphing, okay, and then we can just plug in both equations. So the first one is 2x plus y equals -1. Okay, so there's the first one, and then the second one is y minus x equals 5. Okay, and then we're looking for the intersection. The nice thing about Class Calc is it'll tell us that right away. There it is. The intersection is -2, 3. Okay, so to solve by graphing, you just graph in Class Calc and look for the intersection. Okay, so the solution set for this one would be -2, 3. And so since there's a finite number of solutions, this would be independent. Okay, so we can go ahead and try the next one, which actually I'm just noticing has a little bit of a typo here. There should be an x after the -2/3. Okay, So let's go and graph that in class calc so we can get rid of these two lines we just did and put in the new ones. So 3y plus 2x equals 6, and y equals negative 2 divided by 3 x minus 1. And so if you look here, you can tell these are parallel lines, and if I zoom out, I can see even better that those are never going to intersect each other. So these are parallel lines in this example. So that means this one has no solutions. So the solution set would be empty, and this is an inconsistent system. Okay, so go ahead and pause the video for a second. Try graphing these other two groups here and see if you can find their solutions. Okay, so now that you've tried those on your own, we'll go ahead and do them together. So if I graph the first pair, so 2x plus 4y equals 12, and 2y equals 6 minus x. Now, one of the nice things about while I'm doing this about the Class Calc app, which we've talked about before, is that I didn't have to solve for y or anything like that to be able to graph these, which is a big improvement over the TI graphing calculators you would have used previously. So notice here that these are the exact same line, right? I only see one line. Now, so these are the same line. And we haven't talked about how to write the solution set for that. Well, the solution set for this system, if it's one line, is the set, so brace, of all points x comma y, such that they fall on this line. So 2x plus 4y equals 12. And you could use either form of the equation, but you would need to use one of them. And this would be a dependent system because they're the same line. And then if you graph the last one, we can see that this solution is 3 comma 2. Okay, which is an independent system. Okay, so that's the idea of what we're looking at here. Now, that's only the first way to solve these systems. There's actually algebraic ways we can solve these systems too, but if you wanted to start out by graphing all of these, you could. The only time you're really going to need to use these other methods is when you're dealing with systems that have non-integer or fractions that we recognize answers. But so we want to have multiple tricks. And these other two methods for solving systems are also useful for other things you're going to do in the future. So that's why it's useful to learn these. So the first method is called substitution. So solve for a variable in either one of the original equations. Using the result of step 1, substitute in the other equation for the variable isolated in step 1. Solve the equation, substitute the solution from step 3 into the other equation to solve for the other variable. Check that your ordered pair works in both equations. Okay, so let's go and look at that. So what we want to do is we want to pick one of these two equations and we want to solve for one of the variables. And so we want to pick out the easiest variable to solve for. So in this case, the easiest variable to solve for in the first one is just x, right? Because I'm not going to have to divide by anything. So if we take x plus 2y equals 10 and solve for x, we would subtract 2y from both sides. So we get x equals 10 minus 2y. Okay. So now what we can do with that is, remember, anytime two things are equal to each other, that means they're the same. So that means we can substitute replace them in any other place. So since x equals 10 minus 2y, I can plug 10 minus 2y in for x in the other equation. So that would give us 3 times 10 minus 2y plus 4y equals 8. And now I have an equation with only one variable, so I'm going to be able to solve this and find out a value for y. So distribute, so 30 minus 6y plus 4y equals 8. Combine like terms, so 30 minus 2y equals 8. Subtract 30 from both sides. So negative 2y equals negative 22, and then divide by negative 2. So y equals 11. Okay, and so now that I know what y is, we can take that value for y and replace y in any of the other equations. So if I come back to this equation that I already solved for x, I can substitute in for y. So this will be x equals 10 minus 2 times 11. So that's x equals 10 minus 22. So that's x equals negative 12. Okay, so our solution set would be negative 12 comma 11. That ordered pair, x comma y. Okay, and so that's all there really is to substitution. And if you have a deep independent system like this, where you get a solutions, this is what will happen. You'll solve and you'll get numerical values. However, there are other things that that can happen. So let's practice doing substitution while looking at these other options. So in the second problem here, the easiest variable to solve for is this first x again. So we take x minus 4y equals 3 and solve for x, so add 4y to both sides. So x equals 3 plus 4y. And so now we can do substitution, right? So 3 plus 4y can get plugged in for x in the other equation. So 2 times 3 plus 4y minus 6 equals 8y. Distribute, we get 6 plus 8y minus 6 equals 8y. Combine like terms, and the 6 and negative 6 cancel, so we get 8y equals 8y. Now, that tells us that this equation that we got is an identity, right? That was something that we talked about way back in chapter 1, that this kind of an equation is identity because it's always true. So what that tells us is that these are actually the same line, okay? So I got an identity, so these are the same line. So that means our solution set is all x comma y such that x minus 4y equals 3. And this is a dependent system. Okay, so what that means is no matter what value I pick for x in the first equation, it will have a y in the second equation. So that means that's always going to be true. And then the last one, so we did substitution there, but that's what happens when you get a dependent system. The last one, same setup right here. So for this one, I could add, sorry, I wrote plus 3, I meant minus 3. So if we stick with the same pattern we've been using, I could add 3 to both sides. So I get 5x plus 3 equals y. And now I can substitute this in for y in the other equation. So that's going to be 5x equals 5x plus 3 plus 5. So that's 5x equals 5x plus 8. Subtract 5x from both sides, and you get 0 equals 8. Now, does 0 equal 8? No. So this is what we call an inconsistent equation, and that, in fact, this is an inconsistent system. So there are no solutions, and this system is inconsistent. Okay. So that's the idea of how to use the substitution method and what the different answers could look like. So what I'd like you to do at this point is flip over to page 4. You can pause the video at this point, try these 4 example problems on your own, and then once you're done with them, we can go through them together. Okay, so now that you've given these a try, let's run through them all together. So for the first one, you could solve really for any of these variables. I'm just going to solve for this x. So if you chose to solve for a different variable here, your work's going to look a little different, but you should end up with the same answer. So I get x equals 6 plus y. So now we can substitute that in for x in the other equation. So this will be 6 plus y equals negative 2. So that's 6 plus 2y equals negative 2. Subtract 6 from both sides. So 2y equals negative 8. Divide by 2. So y equals negative 4. And now we can take that negative 4 and we can bring it up and substitute it in here for y. So x equals 6 plus negative 4. So x equals 2. So our final solution here is 2 comma negative 4 because we always put the x coordinate first. Okay, so that's the idea. So in the second one here, this first equation is already solved for y, so I can just use that, right? I can take this negative 2x plus 3 and plug it in for y in the other equation. So that's 2 times negative 2x plus 3 minus x equals 5. Distribute, so that's negative 4x plus 6 minus x equals 5. Combine like terms, so it's negative 5x plus 6 equals 5. Subtract 6 from both sides, and we get negative 5x equals negative 1, and then divide by negative 5 to get x equals 1/5. Okay, and now that we know that x equals 1/5, I can plug that into this equation. So we get y equals negative 2 times 1/5 plus 3. So y equals negative 2/5 plus 3. Negative 2/5 plus 3 is 13/5. So our final solution here is 1/5 comma 13/5. Okay. So that's the idea for number 2. For the third one, the easiest variable to solve for is this b in the second equation. So we take negative 2a plus b equals 8, add 2a to both sides. So b equals 8 plus 2a. Now substitute into the first equation, so 3a plus 2 times 8 plus 2a equals 2. Distribute. Combine like terms. Get the variables on one side by themselves. And then divide to get a by itself. So a is negative 2. And then we can plug that in here to find b. So b equals 8 plus 2 times negative 2. So b equals 8 plus negative 4. So b equals 4. Now, for this one, we always write variables in alphabetical order. So this isn't x and y, but a comes before b in the alphabet. So a comes before b in our ordered pair. Okay. And then the last one, this first x is the easiest thing to solve for. So add 3y to both sides. So we get x equals 7 plus 3y. And now we can substitute in for x. So negative 4 times 7 plus 3y plus 12y equals 28. Distribute to get negative 28 minus 12y plus 12y equals 28. These cancel and we get negative 28 equals 28. Well, does negative 28 equal 28? No. So that means there are no solutions, and this one is inconsistent. The other ones, because they got a finite number of solutions, would be independent. Okay. So that's the idea of solving by substitution. Then the last option we have here for solving these is called the addition method. This is also been called elimination in other textbooks. So if you have learned the elimination method, then you've used this method before, whether you knew it or not. Okay, so let's go ahead and go through using this method. So the first step is multiply one or both equations so that one set of variable terms are opposites. Add the equations together. Because one set of variable terms are opposites, they should cancel. So that means you should be able to now solve for the remaining variable. Then the last step is basically the same as what we did on the other type. So substitute the result from step 3 into one of the equations, solve for the remaining variable, and then check the solution. Okay, now, one of the things you may want to do with some of these is kind of do this first step more than once if you need to. Because one thing you might want to do for these is get rid of the fractions first. So like on the one on the left, to get rid of the fractions, I would multiply by 12, right? Because that's the least common denominator. So that would be 12 times x over 4 is 3x. 12 times y over 3 is 4y equals 0. And then for the one on the right, the number we can multiply by is 24. So if I multiply both sides by 24, so 24 times x over 8 is 3x. 24 times negative y over 6 is negative 4y, and 2 times 24 is 48. Now notice, in this case, I multiplied both equations, and now one of the variable terms are opposites of each other. So what I want to do is I want to add these two equations together. So 3x plus 4y equals 0, plus 3x minus 4y equals 48. And so notice, I need these to be lined up so that I can combine like terms. So 3x plus 3x is 6x. 4y plus negative 4y is 0, and 0 plus 48 is 48, and then just divide by 6, and we get x equals 8. Okay, so x equals 8. And now I can plug that into one of the two original equations to solve for y. So if I plug it in the first one, that would be 8 over 4 plus y over 3 equals 0. So that's 2 plus y over 3 equals 0. Subtract 2 from both sides to get y over 3 equals negative 2. And then multiply both sides by 3. So y equals negative 6. So we get 8 comma negative 6. And one thing I mentioned when we first started doing substitution, but that I haven't reminded you about, so I'll go and do it now, is one way to check these answers is to graph the functions and see if you get the same answer by graphing. The other option is plug these numbers into both equations and make sure they check. So like in this case, it would be 8 divided by 4 plus negative 6 divided by 3. 8 divided by 4 is 2. Negative 6 divided by 3 is negative 2. 2 plus negative 2 equals 0. So that one checks. And then the second one would be 8 divided by 8 is 1. Negative 6 divided by 6 is negative 1. So it would be 1 minus negative 1, which is 2. So that one checks as well. Okay, so that's the idea. Okay. So in this second equation, to make one of the variables opposite, you can multiply the first equation by 2, right? Because that's actually going to make both of these opposites. So if I take 2 times 2x minus y equals 6 times 2, that gives me 4x minus 2y equals 12. And then I can add that to the other one. So negative 4x plus 2y equals 9. Add those together, and you're going to get 0 equals 21, which isn't possible, so there are no solutions for this, and this one is inconsistent. Okay. And then for the second one here, the last one, if I want to do the same idea, if I wanted to make the x's opposites of each other, I would need to multiply it by, well, one way to figure out what you have to multiply by is see what you get if you divide the coefficient on one by the coefficient in the other. So this one's a little trickier because it's got decimals, so we can check, but the coefficient in one term is 1, and in the other one it's 0.05, so that tells me I need to multiply by 20. And notice right now the signs have the terms have the same sign, so I'm going to want to multiply by negative 20. So that I get the opposite. Remember, that's what we're going for here. Not the exact same number, but the opposite. So negative 0.05 times 20 is negative x. Negative 20 times 0.1 is negative 2y. And negative 20 times 0.6 is negative 12. So now we can add that to the other equation. And when we do that, we get 0 equals 0. 0 always equals 0. That's an identity. So that means that the solution set here is all the numbers on that line. So I'm going to use x plus 2y equals 12. And we could say that this is a dependent system. Okay, so that's the idea of how to do addition. So if you want, go and flip over to the next page, and you can pause the video and try doing it for these. Okay, so let's go and go through these. So for the first one, the easiest thing to make opposites is the 2y and the negative y. So if I multiply the first equation by positive 2, that'll happen. So 2 times x is 2x, 2 times negative y is negative 2y, 5 times 2 is 10, and then we're going to add that to the other equation. So 2x plus 3x is 5x, negative 2y plus 2y is 0, 10 plus 10 is 20, divide by 5, and you get x equals 4. And then I can plug that into either of the two first equations. So we could do 4 minus y equals 5, subtract 4 from both sides. The opposite of y equals 1, divide by negative 1. So y equals negative 1. So this one is 4 comma negative 1. Okay. So that's the idea. So the second one, if you notice, the x's and the y's are actually already opposites of each other, so you just have to reorder this. So it's x minus y equals 7, plus the opposite of x plus y equals 5, so they line up. These all cancel, so it's 0 equals 12, which is not true. So there are no solutions, and this one is inconsistent. Okay, for the third one, you could start by getting rid of the fraction. So if I multiply the first equation by 2 on both sides, so that's 2 times x over 2 is x, 2 times y over 2 is y, 5 times 2 is 10. And we could do the same thing for the other one. In this case, we need to multiply by 6, right? Because that's the least common denominator. So that'll give me 6 times 3 halves is 9. 6 times 2 thirds is 4. And now if I multiply the first equation by 4, I'll make it the opposite of the negative 4y. So I can multiply this equation by 4. So we get 4x plus 4y equals 40. And then we can add to that 9x minus 4y equals 12. Add those together and you get 13x equals 52. Divide by 13 and you get x equals 4. And now I can plug that into one of the original equations. So 4 over 2 plus y over 2 equals 5. So 2 plus y over 2 equals 5. Subtract 2. It's y over 2 equals 3. Multiply by 2. And you get y equals 6. So this one is 4 comma 6. And then the last one. In this case, we're going to have to multiply both equations by something would be the easiest way. So I could do the y's here or the x's. So if I wanted to make the x's opposite of each other, I need to multiply the first equation by 3 and the second equation by negative 2. So if I do 3 times 2x plus 3y equals 1 times 3. And if I do negative 2 times 3x minus 5y equals negative 8 times negative 2. Then I get 6x plus 9y equals 3, and negative 6x plus 10y equals 16. Add those together. So 6x plus 9y equals 3, negative 6x plus 10y equals 16. You get 19y equals 19, divide by 19, and you get y equals 1. And then we can substitute that. So 2x plus 3 times 1 equals 1. 2x plus 3 equals 1. Subtract 3. So we get 2x equals negative 2 and divide by 2 to get x equals negative 1. So for this one, we get negative 1 comma 1. Okay, so that's it for section 8.1, the 3 methods for solving systems of equations. In the next section, we'll talk about how to apply this to systems of nonlinear equations. Make sure you're doing your homework, and if you have any questions, as always, feel free to call, email, or text me.